Hello everyone, welcome to LeetCode walkthrough series. So today we are going to solve container with most water problem. The problem says you are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height of I. So what they are saying is they have given an input array called height, of which values represent the heights of different length of these lines. So the first one is height of 1, the second value is height of 8, and so on. Now we need to find two lines in the x-axis such that they store maximum amount of water. So here, as you can see, the second index has value 8 and the last index has value 7. They store the maximum amount of water in between. Okay. Now to solve this, there are two approaches. One is brute force method. Okay. The brute force method says we need to take two pointers and fix the first pointer at the starting index and the second pointer at the next index. Now in the outer loop we need to iterate the inner loop. We need to iterate for every outer loop n number of times. So and compare both of those lengths and take the area between them, I mean the amount of water they can store, and for every comparison you take them and calculate the maximum value. So once the outer loop is fixed here, the inner loop with the second pointer runs n number of times, and then second iteration, ith pointer we increment it, the second pointer runs again almost n number of times, and so on. So this takes for every outer loop we need to run n number of times, such that we need to run n number of times the outer loop n number of times. The complexity is costlier, which is order of n square because of that. So there is better way to solve this by using two pointers. Again, let me show you method. To help you better understand this, I will show this dry run in the whiteboard. Okay, here we have an example and the lengths of each lines are given here. Now let me take the two pointers here and place the left pointer at the start index here, first index, and the right pointer at the end index. Okay, now how we run the pointers is, now let me write it down. First we need, as you can see, the two pointers are at the extreme ends. First take the distance between them, take the distance between left, I mean L is the left pointer, R is the right pointer, L and R, and take the height of these values, the two values L and R which they are pointing to, and find the minimum among these two. Take the minimum height among height of L and, let me write it down here, and height of R. Okay, let me do this way. Okay, after taking these two values, as you can visualize, why we are taking minimum height, because the minimum height becomes the bottleneck, so that the water fills up only till this point, and the remaining, if you try to fill it, it will overflow. So that is the reason minimum height is the bottleneck. Now after taking these two values, just visualize this as a rectangle area. Okay, we are finding the area between both. Take area, which is the distance between these two L and R, distance between L and R multiplied by the minimum height between these two, min of, okay, I'll just write it down here, this multiplied by min of h of height of L and height of R. So we get the area between these two, and take an variable called as current maximum area, current max, let's call it current max, equal to 0. So I'll just define this above area. Okay, initially the current max is set to 0. We will append, we will take maximum of the calculated area and the current max area. Current max equal to max of current max and the area which we got from calculating this. Okay, so once we calculated the maximum area, we will increment based on, we do the pointer movement based on the minimum height. The side which has the minimum height, we move that pointer. Suppose if the L pointer has the minimum height, for example here, if let's call it h for height. Okay, h of L is the minimum, h of then R, value of R, then move the left pointer, else move the right pointer, backwards, in the backwards direction, decrease the right pointer. Okay, why we are doing this? Because we need maximum area, so that the smaller height, if it approaches to the maximum height, that's where we get the highest amount of water. What I mean to say is, the highest we already know, the smallest value must approach till the highest value, so that there are chances of getting highest amount of water. Let's see. Okay, this is all the algorithm. Now let me trace this. Okay, now height among these two is this one, this is the lesser one. We calculate the area. Let me write it down here somewhere. Okay, the distance is 0, 1, 2, 3, 5, 6, 7, 11. Okay, there are 11 indices. Now 11 minus, since the R is pointing at the 10th index, okay, 10 minus 0, the width is 10, 10 minus 0 is 10, and height, min height is 6, and height is 6. So we calculate the area is 60, and the current max is keep this here. Okay. Now the current max is 60 because we take maximum height. Now L moves forward because that is the lesser height here, and it comes here. So L is 2 and R is 9. So the height becomes 2 and width becomes what was earlier? Yeah, 9. So 9 into 2, area is 18. 18 is lesser than 60, so max stays the 60. And again we move the left pointer because that's the shorter one. It comes here. So value of L is 5. So that makes the minimum height as 5 because R is still the bigger height. And width becomes 8. So 8 5 is 40, and still the area is maximum area is 60. Okay. Now again L moves ahead, becomes 3. Now min height is again 3, and we find that width gotten shorter, and we find the area is 21, and again it's smaller than 60, max stays the 60. Now again L moves forward, and now it's at value 8. We find the minimum height now as 8, and width becomes 6. So at 6 of 48, so it's still lesser than 60. Then increment the left pointer. Okay. Now L is pointing at the value 10. So the min height now becomes 9 because R is lesser than the value of L, and the width becomes 5. Now what we do, calculate the area, max area. So it's still 45, so the area stays 60. Now since H is smaller, we go to the else condition here. So we squeeze R towards left direction. Now we see that the min height is 7. Okay, and the width becomes 4. Now we calculate the area. It's 28. Its area is max is 60. Again the smaller side is 7, so we decrement the right pointer inwards. Okay, it points to 4 now. So the min height is 4, and the max height is, the width is 3. So we are taking the distance between L and R, so it's 3. So the area again becomes 12, so it's lesser. So we move the right pointer, which is the smallest. Right pointer moves inwards, or here, and now the min height is 2, and the width becomes 2 as well, and 2 is a 4, so height is still the largest, 60, and move the smallest pointer inwards. Now the R becomes 1, and we update the min value as min height as 1, and width becomes 1. So we take, we can see we can't store any more water given that the lines are adjacent to each other. So this is where the loop breaks. When L is lesser than right, L is lesser than right, the pointer L value, not value, just the pointer's value. So that's where the loop breaks. So this is 1, this again fails, and R moves inwards. In the next iteration, now it terminates. So these two collide, now loop gets terminated, hence we get the maximum area 60. So actually this is a bad example that I created myself. So there could be I could have come up with a better example so that you can see, could have seen the maximum area changes along the way. Okay, so now this is 60. Okay, now we copy this algorithm to the our LeetCode area, coding area here for your understanding. Okay. Yes. Do this and then. Okay. Now let's code the solution. Algorithm is in place. Let's do it. Okay. Let me take the first as left pointer equal to 0. Let me do this right, left and right equal to 0. One off nums. I am initializing both pointers at the extreme edges at first, and I will take current max value initialized to 0. So we inside the loop, I forgot to add the loop over here. The loop is for left, for right is it is while left is lesser than right? Correct. Yeah, my bad. Correct. It's the while loop, so that pointers meet each other so that it terminates. While left is less than right. Okay. We take the width first. Width equal to right minus left. And the height is the min height, so we take min height as minimum of height of left and height of right. Okay, then calculate the area, width to min height, and find the maximum area, current max. If it is maximum, then this take max of current max, and area comes next. So we get the maximum area, current maximum area. And now pointer incrementation. If the height of left side is lesser than height of right side, then we increment the left pointer. Okay, otherwise just decrement the right pointer. Okay, and at the end we have to return the maximum value. After the loop ends, the current maximum is calculated. We just have to return the current max. Okay, this is the solution. Let me run it. Oh, my bad. I took the nums here. Should be height. The input array is height. Okay. Let's see if it works. Okay. Solution is successful. Let me submit it. Okay, the solution works. Now, in the brute force approach, the time complexity is order of n square, as I discussed earlier. Now, for this approach, it runs in single pass by comparing both of these pointers' heights and width between each other, and finding out the area between them. So both pointers squeezes inwards, and finally they meet each other. The loop terminates. Hence the loop, the array is traversed only once, which is n number of times, so it's order of n time complexity. So complexity is order of n, and space complexity is, we are not using any extra space here apart from the given input height array, unless apart from these apart from these values like left, right, and current max variables. Those are order of 1 variables, so the space is just order of 1. Okay, this is the solution. So thanks for watching.